Welcome to where time falls quiet.
The Younger Dryas, when the sun failed and winter returned. Take a moment to subscribe, so this place of calm is always here for you. What if everything we believe about the ancients, their superstitions, their myths, their fevered prophecies scrawled on clay and carved into stone, was never mythology at all? What if the stories we've dismissed as primitive imagination were actually the most sophisticated warning system ever devised, encoded by people who had seen the sky break open and survived to document precisely what preceded it? Tonight, you're going to discover something that archaeology has whispered about in footnotes but never quite allowed itself to say aloud. That ancient civilizations didn't worship celestial destruction out of ignorance. They documented it with the precision of traumatized witnesses preparing their descendants for the next time the heavens would burn. The clay tablet sits in a climate-controlled vault at the University of Pennsylvania, catalogued as CBS 10673. It's unremarkable in size, no larger than a paperback novel, its surface covered in the wedge-shaped impressions of cuneiform script. When Leonard Woolley first excavated it from the Royal Cemetery of Ur in 1928, he expected another administrative record, another grain inventory or temple accounting. What he found instead was a document that should not exist according to our timeline of human knowledge. The tablet lists astronomical observations with mathematical precision that wouldn't be independently rediscovered by Western until the 16th century, calculations of planetary synodic periods, eclipse prediction tables, and most disturbing of all, a systematic catalogue of what the text calls the fire stars that cross the boundary between Earth and heaven. The language is clinical, almost bureaucratic. There's no poetry here, no religious ecstasy or prophetic fever. The scribe who pressed these symbols into wet clay 3,800 years ago was documenting observed phenomena with the same matter-of-fact precision used for recording livestock or measuring grain stores. The text describes atmospheric disturbances, changes in celestial mechanics, and most specifically, the behavior of objects that appear in the night sky, grow brighter over successive observations, and then descend through the air, bringing the gods' fire to earth. End. The mathematical precision is what makes scholars uncomfortable. These weren't superstitious farmers mistaking meteors for divine anger. These were trained observers maintaining a continuous record of near-Earth objects, tracking their trajectories, calculating their approach vectors, and attempting to predict when the next bombardment would occur. But here's where the silence in the academic halls begins to hum with implications. The Sumerian tablet wasn't unique. In 1872, when George Smith translated the Epic of Gilgamesh from the library of Ashurbanipal, buried beneath the ruins of Nineveh, he discovered that the famous flood narrative included details no one discusses in undergraduate mythology courses. Before the deluge, the text describes 7 judges of hell, raising their torches, lighting the land with their flames, and creating a conflagration so intense that even the gods were terrified. The description continues with atmospheric phenomena. A darkness that falls at noon, winds from all directions that tear at the earth, and waters that rise not just from below, but seem to originate from the impact of something massive striking the ocean. The text specifies that Utnapishtim, the flood hero, was warned in advance by the god Ea, who provided not just the instruction to build an ark, but detailed specifications for its construction. Specifications that modern naval engineers have confirmed would create a vessel stable enough to survive massive displacement waves. Thousands of miles away, in the Dresden Codex of the Maya, a text preserved through Spanish conquest and environmental decay, we find astronomical tables calculated with such precision that they accurately predict Venus transits across centuries. But buried within these calculations is something else, a systematic notation for what the Maya called sky serpents, celestial objects that appeared periodically and brought destruction. The glyphs describe not just the events themselves, but the warning signs, changes in the color of the horizon at sunset, unusual animal behavior, and, most tellingly, mathematical calculations for predicting when these serpents would return, based on observed cycles spanning thousands of years. The Maya weren't alone in this obsession. Egyptian temple inscriptions from the pre-dynastic period contain hieroglyphic sequences describing the time when the sky burned and the year when Seth's fire consumed the delta. These aren't metaphors buried in creation mythology. They're historical markers used to date other events, written in the same factual tone as pharaonic year counts and Nile flood measurements. Imagine you're a priest astronomer in ancient Uruk, 5,000 years ago. Your position isn't religious in the modern sense. It's practical, essential to survival. You spend your nights on the ziggurat summit, tracking the movements of celestial bodies with an accuracy that won't be matched until the invention of the telescope. You maintain records passed down through generations, tablets inscribed by your predecessors going back centuries, possibly millennia. These records document patterns, not just the predictable cycles of planets and stars, but the irregular appearances of objects that don't follow the established order. Some appear, grow bright, and fade. Others descend, bringing fire and devastation. Your job, the sacred duty passed from teacher to student across generations, is to calculate when the next impact will occur, to watch for the warning signs your predecessors documented, and to prepare your civilization for survival. The evidence isn't limited to texts. In 1991, geologist Robert Schoch examined the Great Sphinx of Giza and discovered something that contradicted every assumption about its construction date. The weathering patterns on the Sphinx's body weren't the result of wind and sand erosion, as expected in the desert climate. They were the unmistakable signatures of water erosion, deep vertical channels carved by sustained rainfall that hadn't occurred in the Giza Plateau for at least 7,000 years, pushing the Sphinx's origin back to a period before Egyptian civilization supposedly existed. But the Egyptian chronology itself contains a disturbing notation. The inventory stela, discovered by Auguste Mariette in 1858, describes the 4th dynasty pharaoh Khufu, discovering the Sphinx already ancient and ordering its restoration. The text is explicit. Khufu did not build the Sphinx. He found it, already weathered, already damaged by catastrophe, and attempted to preserve what an earlier, forgotten civilization had created. This is where orthodox archaeology encounters its existential crisis. If the Sphinx predates dynastic Egypt, if Sumerian astronomical records describe systematic observations spanning epochs before their supposed invention of writing, if the Maya calculated celestial cycles requiring continuous observation over time frames longer than their civilization's known existence, then we're not looking at the origin of civilization. We're looking at its restoration after something that nearly erased it entirely. The mathematics on those Sumerian tablets, the architectural precision of megalithic structures aligned to celestial coordinates, the convergent flood narratives across cultures separated by oceans, these aren't the fumbling first steps of emerging societies learning to organize and build. These are the desperate efforts of survivors trying to preserve and reconstruct knowledge inherited from predecessors who understood something we've only recently rediscovered: that Earth exists in a cosmic shooting gallery, And periodic bombardment isn't myth. It's geology, it's archaeology. It's the pattern written in impact craters, iridium layers, and the sudden collapses of civilizations that had no reason to vanish except that something fell from the sky. The ancient astronomers knew. The evidence is carved in stone, pressed into clay, and encoded in the mathematical precision of structures built to outlast catastrophe. They watched the sky not with religious superstition, but with the focused attention of survivors who understood that the fire had come before and would come again. They calculated the cycles, documented the warning signs, and embedded this knowledge so deeply into their culture that it survived as mythology long after its practical purpose was forgotten. The question that should make your skin tingle with unease isn't whether they believed in celestial destruction. The question is, what did they see that made them so certain they needed to warn us? Language doesn't lie about what it witnessed. It preserves trauma with a precision that outlasts stone, embedding the vocabulary of catastrophe so deeply into grammatical structure that it survives millennia after its original context is forgotten. When linguists compare ancient texts across cultures that never contacted each other, separated by oceans and thousands of years, they expect divergence, completely different ways of describing similar phenomena. What they find instead in the specific context of celestial destruction is something that should be impossible. A convergent technical vocabulary describing not just fire from the sky in general terms, but the specific stages, characteristics, and atmospheric effects of objects entering Earth's atmosphere at terminal velocity. These weren't poets independently inventing colourful metaphors for divine anger. These were administrative scribes, temple record keepers, and court astronomers documenting observed events with the clinical detachment of witnesses filing incident reports. The Sumerian term an.gal appears in astronomical texts dating to the 27th century before the Common Era. Traditional translations render it poetically as Great Fire of Heaven or Divine Flame from Above, which safely contains it within the realm of religious mythology. But when you examine its usage in administrative contexts, boundary disputes, legal documents, year-name formulae, the term functions as a specific technical descriptor. Texts describe the an.ta.gal as having predictable characteristics. It begins as a point of light that grows brighter over successive nights, produces a sound described with the word rigmu, which specifically denotes rolling thunder rather than sharp cracks, creates winds in multiple directions simultaneously, and leaves behind a substance the texts call black rain that ruins crops and poisons water sources. This isn't the language of religious ecstasy. This is observational data recorded with the precision of modern meteorological reports, describing atmospheric entry, sonic boom, impact-generated winds, and the fallout of particulate debris. 3,000 miles west, Egyptian hieroglyphic texts from the pre-dynastic and early dynastic periods contain a phrase that temple priests called Sekhmet's arrow. The goddess Sekhmet was associated with destruction, but the contexts in which her arrow appears are revealing. The pyramid texts, among the oldest religious writings in human history, contain a passage that describes this arrow as that which descends from the night, burning, which the eye cannot follow, which brings the hot wind and the shaking earth. The verb tense is specific, not mythological past, not eternal present of divine action, but the simple past tense used for historical events. More tellingly, the texts associate Sekhmet's arrow with specific years in the chronology, using it as a temporal marker to date other events. One inscription from Abydos references the year after Sekhmet's arrow fell in the delta, when the great water came inland. This isn't creation mythology. This is chronological notation, placing a celestial impact event in historical sequence with other documented occurrences. The linguistic pattern becomes unavoidable when you examine Sanskrit texts from the Indus Valley. The Rig Veda, composed between 1500 and 1200 before the Common Era, but preserving oral traditions potentially thousands of years older, contains detailed descriptions of what it calls Indra's bolt. Western scholars have traditionally interpreted this as metaphorical lightning, the weapon of a storm god. But the descriptions are far too specific for meteorological phenomena. The text describes objects that tear through the vault of heaven with the sound of 1,000 chariots, that burn brighter than the sun at midday, that strike the earth and mountains tremble, and, most specifically, that appear when certain stars align in their courses. The last detail is crucial. It suggests systematic observation and prediction, not random divine caprice. The Vedic astronomers were tracking something, calculating when it would return, and encoding this knowledge in hymns designed to survive oral transmission across generations. When Spanish conquistadors first encountered Maya texts in the 16th century, they burned most of them as heretical. The few that survived, like the Dresden Codex and the Popol Vuh, contain a term that appears repeatedly in astronomical contexts. Kand Zul, literally sky serpent. Bishop Diego de Landa, who ironically both destroyed and documented Maya culture, noted that the Maya used this term specifically for celestial objects that moved against the fixed stars, grew in brightness, and brought fire to earth. The Dresden Codex contains calculation tables for predicting Kand Zul appearances, using the same mathematical precision applied to Venus transits and eclipse predictions. The Maya weren't making up random monster stories. They were maintaining an astronomical database, tracking near-Earth objects with periodicities they had calculated through sustained observation. Their sky serpent wasn't a deity or symbol. It was technical terminology for a specific class of astronomical phenomenon that posed an existential threat. The linguistic convergence extends beyond terminology to grammatical structure. In Sumerian, Egyptian, Sanskrit, and Maya texts, descriptions of celestial impacts follow nearly identical narrative sequences. First appearance as a point of light, gradual brightening over multiple observations, atmospheric disturbances preceding impact, the impact event itself with specific physical effects, and aftermath including climate disruption and flooding. This narrative structure isn't cultural borrowing. These civilizations had no contact with each other. It's the structure imposed by reality. The sequence of events that actually occurs when a significant object enters Earth's atmosphere. The languages differ completely in every other respect, yet in this one specific context, they converge on identical descriptive frameworks because they're documenting the same type of event. The Chinese oracle bone inscriptions from the Shang dynasty, dating to 1300 before the Common Era, contain characters that scholars translate as starfall or heavenstone. But the contexts reveal something more precise. The inscriptions ask divinatory questions. If the star falls in the eastern quarter, will the harvest fail? If the heavenstone strikes water, will the river flood? These aren't abstract religious queries. They're risk assessments based on observed correlations between impact events and subsequent environmental catastrophes. The Shang court maintained astronomical observers specifically tasked with watching for these events and calculating their likely effects. The oracle bones weren't superstitious fortune-telling. They were early probability calculations, attempting to model outcomes based on impact location and magnitude. What makes this linguistic convergence genuinely unsettling is the level of technical specificity. These cultures independently developed vocabularies for distinguishing between different types of aerial phenomena. Meteors that burn up in the atmosphere versus objects that reach the ground, airbursts versus ground impacts, land strikes versus ocean strikes. They had terms for impact-generated tsunami waves distinct from regular flooding. They described the specific color and composition of atmospheric debris following major impacts. This degree of taxonomic precision doesn't emerge from occasional random observations. It requires sustained, systematic study of repeated events, carefully documented and analyzed across generations. The linguistic evidence suggests that for these ancient cultures, celestial bombardment wasn't a rare mythological event. It was a recurring hazard that required constant monitoring and had its own specialized technical vocabulary like modern meteorology or seismology. The Proto-Indo-European root that eventually evolved into the Greek word aster, the Latin stella, and dozens of other words for stars contains a fascinating grammatical feature. It has distinct forms for stars that stay fixed versus stars that move, and, crucially, a third category for celestial objects that fall with burning. This linguistic fossil, embedded in the very structure of languages spoken by billions of people today, preserves a time when the distinction between stable celestial objects and dangerous falling objects was important enough to encode at the most fundamental level of language structure. Our ancestors didn't just see objects fall from the sky occasionally. They saw it often enough, with consequences severe enough, that the vocabulary for distinguishing types of celestial threats became grammatically essential. Like the difference between rock and boulder matters when one might crush you. The clay doesn't lie, and neither does language. When multiple ancient cultures, isolated from each other by geography and time, independently developed nearly identical technical vocabularies for describing celestial impacts, complete with specific terminology for atmospheric entry characteristics, sonic phenomena, impact effects, and aftermath. We're not looking at mythology, we're looking at a technical literature, a body of systematic knowledge accumulated through observation and carefully preserved in the only storage medium available. Human memory encoded in language precise enough to survive translation across generations. The ancient texts weren't warning about divine punishment. They were documenting geological and astronomical realities their descendants would need to recognize when the sky began burning again. The earth remembers what we've forgotten. Buried beneath millennia of sediment, encoded in the molecular composition of ice cores and lake beds, preserved in the scorched layers of soil that mark the boundary between one world and the next, the geological record confirms what ancient texts insisted was real, that approximately 12,800 years ago, something catastrophic happened to Earth's atmosphere and surface. This wasn't gradual climate change or localized natural disaster. This was a planetary-scale event that left signatures in the stratigraphic record on every continent simultaneously. A layer of shocked quartz, elevated platinum group elements, carbon spherules consistent with massive biomass burning, and a sudden temperature drop that plunged the planet into centuries of cold darkness. The geologists call it the Younger Dryas boundary layer. The ancient chroniclers called it the time when the sun failed and the years when fire fell from heaven and winter came in summer. Both descriptions, separated by 12,000 years of human history, are documenting the same event. In 1967, a research team drilling ice cores in Greenland discovered something that contradicted the prevailing model of gradual climate transition. The ice layers showed an abrupt temperature drop of approximately 15 degrees Celsius, occurring within a span of less than 3 years. This wasn't the slow cooling expected from orbital mechanics or ocean current shifts. This was rapid-onset global cooling triggered by a sudden influx of atmospheric particulates that blocked solar radiation. The ice cores contained elevated concentrations of platinum, iridium, and other elements rare in Earth's crust, but common in extraterrestrial objects. More tellingly, the layer contained microscopic diamonds formed under extreme pressure and temperature. Nanodiamonds that only form during hypervelocity impacts or atmospheric airburst events. The evidence was unambiguous. Something from space had either struck Earth or exploded in the atmosphere with sufficient force to distribute impact markers across the entire northern hemisphere. The Sumerian King List, that curious document we encountered earlier with its impossibly long reign durations, contains a phrase that appears immediately after the legendary antediluvian kings. Then, the flood swept over. But the text that follows this notation describes something more complex than simple inundation. It speaks of the black rain that burned the fields, of the winter that came in the month of planting, of crops that withered in darkness, though water fell from the sky. These aren't descriptions of a regional river flood, even a catastrophic one. These are descriptions of impact winter, the atmospheric loading of particulates that blocks sunlight, causes temperature collapse, and creates acidic precipitation from atmospheric chemical reactions. The Sumerian scribes were documenting the same event the Greenland ice cores recorded, but from the human perspective on the ground, watching their world darken and freeze. Thousands of miles away, in the sediment layers of North American Carolina bays, geologists discovered something equally disturbing. These elliptical depressions, numbering in the hundreds of thousands, all share the same northwest to southeast orientation and show evidence of simultaneous formation. The sediment fill contains the same markers found in the ice cores: elevated platinum group elements, carbon spherules from massive wildfires, and shocked quartz indicating extreme pressure events. Radiocarbon dating places their formation at 12,800 years before present, the exact timing of the Younger Dryas boundary. The orientation and distribution pattern is consistent with a fragmented comet or asteroid entering Earth's atmosphere from the northwest, creating an airburst field that devastated the North American continent. This wasn't theoretical modeling. This was physical evidence of continent-scale destruction preserved in the geological record. The Ojibwe oral traditions of the Great Lakes region contain stories of the time when the sky fell and the stars that burned the earth. Anthropologists dismissed these as creation myths until the geological evidence forced a reassessment. The oral histories describe specific details: the sky lighting up brighter than day in the northern horizon, a sound like all the thunder that ever was, forests igniting across vast distances simultaneously, and massive flooding as the great ice mountains melted. The timing encoded in their generational countback system places these events at approximately 12,000 to 13,000 years ago. The Ojibwe weren't preserving mythology. They were maintaining eyewitness testimony, passed down through 300 generations, describing the moment when the Laurentide ice sheet was catastrophically destabilized by airbursts and impacts, releasing meltwater floods that carved the scablands and raised global sea levels by meters within decades. In the Middle East, the archaeological site of Abu Huraira in Syria contains a layer dating to 12,800 years before present that tells a story of sudden catastrophe. The settlement shows evidence of continuous occupation, then an abrupt layer of melted glass, trinitite-like materials that form when sand is exposed to extreme heat, well above anything achievable with ancient technology. Mixed with this glass layer are the remains of buildings that burned instantaneously, their organic materials converted to carbon, but their structure preserved by the speed of incineration. Above this destruction layer, after a gap representing abandonment, occupation resumes but with a completely different material culture, as if survivors had to restart civilization from rudimentary knowledge. The site perfectly matches the textual accounts: catastrophic fire from the sky, destruction of existing culture, and restart by survivors who remembered some, but not all, of the previous knowledge. The Younger Dryas boundary layer appears in stratigraphic sequences across North America, Europe, the Middle East, and Asia. It's not localized, it's global. Wherever geologists core deep enough and date precisely enough, they find the same signature: a sudden influx of extraterrestrial materials, evidence of massive biomass burning, climate disruption markers, and frequently an abandonment gap in human occupation followed by cultural restart. The layer appears in lake sediments in Central America containing elevated platinum and nanodiamonds. It appears in European peat bogs showing simultaneous forest fire markers across thousands of kilometers. It appears in Chinese loess deposits containing the same shocked quartz and melt spherules found in North American sites. This is the geological confirmation of what ancient texts insisted happened: a global catastrophe originating from celestial bombardment. But here's what makes the ancient chronicles genuinely remarkable. They didn't just document the impact event itself. They documented the warning signs that preceded it. Babylonian astronomical diaries, compiled from earlier Sumerian sources, contain references to the time before the flood, when the star paths changed and new lights appeared in the fixed heaven. Egyptian texts describe a period before the Great Destruction, when the order of the sky was disturbed, and priests observed wandering fires that grew night by night. The Popol Vuh describes a time before the first dawn was darkened, when the sky watchers saw the fire serpent approaching and tried to warn the people. But the people did not believe until the burning came. These aren't post hoc mythological explanations. These are descriptions of the weeks or months leading up to impact, when trained astronomical observers would have noticed approaching objects, tracked their brightening, calculated their trajectories, and attempted to warn their populations. The geological record can tell us what happened. The chemical signatures, the particle distributions, the temperature proxies, all confirm catastrophic bombardment 12,800 years ago. But only the textual record, the chronicles preserved by survivors and their descendants, can tell us what it was like to watch it approach, to see new lights appear in the night sky and grow brighter with each observation, to hear the priests and astronomers issue warnings that most people dismissed as superstitious fear, to witness the horizon begin to glow, not with sunrise, but with incoming fire, to experience the moment when theoretical astronomical calculations became lived catastrophe, when the mathematics of orbital mechanics translated into cities burning and ice sheets collapsing. The ancient texts give voice to what the geology can only show in silent evidence: the terror of watching the sky betray its constancy and become a source of annihilation. The convergence of geological and textual evidence isn't coincidence, it's corroboration. When ice cores from Greenland, sediment layers from Syria, impact markers from North America, and chronicle fragments from Mesopotamia all point to the same event at the same time with consistent details, we're not dealing with myth or exaggeration. We're dealing with the documented reality of planetary catastrophe that nearly erased human civilization and forced survivors to restart with whatever knowledge they could preserve. The earth kept the physical record. The ancients kept the human record. Together, they testify to a truth we've spent centuries dismissing, that the cosmos is not benign, that bombardment is periodic, and that our ancestors knew this because they survived it. Mathematics doesn't emerge from nothing. It develops in response to need, to problems that demand quantitative solutions, to questions where approximation means death and precision means survival. When modern scholars first decoded Sumerian mathematical tablets in the early 20th century, they expected to find basic arithmetic, addition, subtraction, methods for calculating area and volume sufficient for agriculture and construction. What they found instead was mathematics that shouldn't exist for another 3,000 years. Sophisticated algorithms for calculating planetary positions, methods for solving cubic equations, tables of reciprocals extending to numbers in the millions, and most disturbing of all, systematic calculations for predicting the orbital mechanics of objects that posed existential threats. This wasn't theoretical mathematics developed by philosophers contemplating abstract beauty. This was applied mathematics developed by a civilization desperately trying to calculate when death would fall from the sky again. The tablet catalogued as Plimpton 322 sits in Columbia University's rare book library, a fragment of baked clay covered in neat columns of cuneiform numbers. For decades after its acquisition in 1922, scholars assumed it was a teacher's practice tablet for arithmetic drills. Then, in 1945, Otto Neugebauer and Abraham Sachs realized what they were actually looking at: a table of Pythagorean triples, sets of three numbers that satisfy the equation where the square of one number plus the square of another equals the square of the third. But this wasn't a random collection of examples. The tablet contained 15 precisely calculated triples generated by a systematic algorithm, demonstrating that Babylonian mathematicians, inheriting Sumerian knowledge, understood the underlying mathematical relationships more than 1,000 years before Pythagoras was born. The algorithm they used requires understanding of algebraic principles and numerical relationships that European mathematics wouldn't rediscover until the 16th century. But why would a Bronze Age civilization need such sophisticated mathematical tools? The answer emerges when you examine what they were calculating. Other tablets from the same period contain tables for what modern astronomers call synodic periods, the time it takes for a celestial body to return to the same position relative to Earth. The Sumerian calculations for the synodic period of Venus are accurate to within hours over an 8-year cycle. Their calculations for Mars match modern computer models within less than 1% error. These weren't casual observations. This was systematic data collection and mathematical modeling spanning decades, possibly centuries, requiring institutional continuity and a compelling reason to maintain such precise records. The compelling reason appears repeatedly in astronomical omen texts, predicting when fire stars would return, calculating trajectories of objects that cross the boundary between heaven and earth. The tablet known as Muel.apin, compiled around 700 before the Common Era, but containing astronomical knowledge dated to at least 1,500 years earlier, presents something remarkable. A systematic catalogue of celestial objects organized not just by their position in the sky, but by their behavior and threat level. The text distinguishes between fixed stars that maintain their positions, wandering stars that follow predictable paths, the planets, and a third category of objects described as fire stars that appear in their time. This third category receives disproportionate mathematical attention. The tablet contains calculation methods for predicting their appearances, formulas for estimating their approach velocities based on brightness changes over successive observations, and, most tellingly, geometric methods for calculating impact zones based on observed trajectory angles. This is orbital mechanics expressed in the mathematical language available to Bronze Age astronomers, but describing the same physical realities that modern space agencies calculate with computers. The base 60 number system the Sumerians developed reveals the sophistication of their astronomical calculations. This sexagesimal system, the same one we still use for measuring time and angles, wasn't chosen arbitrarily. 60 has more devices than any smaller number, making it ideal for astronomical calculations involving circular orbits and periodic phenomena. The system allows for precise fractional calculations without requiring decimal notation. When you examine Sumerian astronomical tables, you find calculations carried out to 6 sexagesimal places, equivalent to precision of better than 1 part in 46 million. This level of precision serves no purpose for agricultural calendars or temple ritual scheduling. It's the precision required for calculating long-period orbital mechanics, for distinguishing between objects that will pass harmlessly and objects on collision courses, for predicting centuries in advance when specific celestial configurations would increase bombardment risk. The Venus tablet of Amisaduqa, one of the oldest surviving astronomical texts, contains 21 years of observations recording Venus's first and last visibility, its periods of invisibility, and its positions relative to other celestial markers. Modern astronomical analysis confirms these observations are accurate and date to approximately 1637 before the Common Era. But embedded within these Venus observations is something else: notations for fire star appearances correlated with specific Venus positions. The text suggests that ancient astronomers had identified a relationship between Venus's position in its orbit and increased activity of near-Earth objects. A correlation that modern astronomy has partially confirmed through studying the orbital resonances that can perturb objects in the inner solar system. The Babylonians weren't just tracking Venus out of religious devotion. They were using Venus as an astronomical clock to predict periods of elevated bombardment risk. The mathematical sophistication extends to calculations that modern assumed were impossible before telescopic astronomy. Sumerian tables contain accurate values for the sidereal periods of all visible planets, the time it takes each planet to complete one orbit relative to the fixed stars. Calculating sidereal periods requires distinguishing between a planet's apparent motion, caused by Earth's own orbit, and its true orbital motion, a problem that demands sustained observation over decades and mathematical methods for untangling superimposed periodic cycles. The Sumerian values for Jupiter's sidereal period differ from modern measurements by less than 2%. For Saturn, the accuracy is even more remarkable, within 1% of values calculated using modern orbital dynamics. How did naked-eye observers achieve this precision? The answer requires assuming institutional astronomical programs spanning generations, carefully maintaining observational records and continuously refining mathematical models. This wasn't casual stargazing. This was a scientific project with the scope and continuity of modern space agencies. But the most unsettling mathematical evidence appears in texts dealing with what Assyriologists call ominous astronomical events. These tablets, found at Nineveh in the library of Ashurbanipal, but copying earlier Babylonian and Sumerian sources, contain formulas for calculating what we would now call impact probability. The texts describe methods for estimating an object's size based on its apparent brightness, calculating its likely trajectory from multiple observations at different dates, and predicting its closest approach to Earth. One particularly detailed tablet describes a computational method strikingly similar to modern least squares approximation for fitting observational data to predicted orbits. The mathematical formalism is different, expressed geometrically rather than algebraically, but the underlying logic is identical. Use multiple observations to constrain possible trajectories and calculate the most probable path. This is the mathematics of threat assessment, developed by a civilization that had watched objects fall from the sky often enough to need systematic methods for predicting the next impact. The question that haunts every scholar who studies these tablets is the same question that should trouble anyone who reads them. Why did the Sumerians develop such sophisticated astronomical mathematics? Agricultural societies need calendars, but lunar cycles and solar years require only basic arithmetic. Temple rituals need celestial timing, but naked-eye observation of star positions suffices. Navigation needs star positions, but static star maps work adequately. None of these practical necessities require sexagesimal calculation systems precise to 6 places, systematic tracking of planetary synodic periods over centuries, or mathematical methods for calculating celestial threat trajectories. The only necessity that requires this level of mathematical sophistication is survival in the face of periodic bombardment. The Sumerians developed advanced mathematics for the same reason we develop nuclear physics and rocket, because the alternative to understanding the threat is extinction. The clay tablets aren't abstract mathematical exercises. They're emergency protocols encoded in cuneiform, desperate calculations performed by priest astronomers who understood that their civilization's survival depended on predicting when the sky would burn again. The precision, the institutional continuity, the resources devoted to astronomical observation and mathematical calculation. All of it makes sense only if you accept what the texts themselves explicitly state: that fire fell from heaven, that it had happened before, that it would happen again, and that calculation was humanity's only warning system. The mathematics of the Sumerians wasn't the beginning of human mathematical achievement. It was the preservation and application of knowledge inherited from predecessors who had learned, through catastrophic experience, that survival requires watching the sky with mathematical precision and never forgetting what the calculations mean. Stone doesn't forget. It doesn't erode like memory, doesn't corrupt like oral tradition, doesn't burn like papyrus or crumble like clay. When you need to send a message across thousands of years, through catastrophe and civilization collapse, through the rise and fall of empires and the forgetting and relearning of languages, you carve it into stone and make it so massive, so precisely engineered, so impossible to ignore, that future generations will have no choice but to ask why. The great megalithic structures scattered across the planet, pyramids, temples, stone circles, astronomical alignments, weren't built to honor gods or kings, at least not primarily. They were built as survival protocols, as warning systems, as time capsules designed to preserve essential knowledge through the next cycle of destruction. The impossible precision, the astronomical alignments, the massive scale that defies explanation given Bronze Age technology, all of it makes sense when you understand that these structures were meant to survive what their builders knew was coming. The Great Pyramid of Giza embodies this dual purpose with mathematical clarity. Its base is level to within 2.1 centimeters across a 13-acre footprint, an engineering tolerance that modern construction struggles to match. The 4 sides align to the cardinal directions with an error margin of less than 1/15 of a single degree. The dimensions encode mathematical relationships. The ratio of the pyramid's height to its base perimeter equals the ratio of a circle's radius to its circumference, pi expressed in architecture. These aren't accidents or approximations. This is precision mathematics, built at a scale designed to survive millennia. But why? The standard explanation, royal tomb, falls apart under examination. No pharaonic burial has ever been found in the Great Pyramid. The so-called King's Chamber and Queen's Chamber show none of the decorative hieroglyphs, religious iconography, or funerary inscriptions that characterize actual Egyptian tombs. The pyramid's internal passages and chambers serve a different function entirely. The ascending and descending passages of the Great Pyramid point to specific celestial coordinates with the same precision the exterior demonstrates. The descending passage, at the time of construction, aligned perfectly with Alpha Draconis, the pole star of 2600 before the Common Era. The ascending passage aligned with Alcyone in the Pleiades cluster. But these alignments weren't static. They accounted for precession, the slow wobble of Earth's axis that causes the celestial poles to trace a circle through the stars over 25,920 years. The pyramid's architects understood precession and built its astronomical alignments to mark a specific moment in the precessional cycle. They weren't just building for their present. They were building a structure that would maintain its astronomical function across multiple precessional periods, a clock designed to run for 50,000 years or more. This level of astronomical sophistication suggests they were encoding information about celestial cycles that posed recurring threats. The so-called air shafts in the Great Pyramid aren't air shafts. They're too narrow, too precisely angled, and they don't reach the pyramid's exterior surface. Instead, they point at specific stars. The southern shaft from the King's Chamber targeted Orion's belt, associated in Egyptian mythology with Osiris and the afterlife. The southern shaft from the Queen's Chamber pointed at Sirius, the star whose heliacal rising marked the beginning of the Egyptian year and the Nile flood. But the northern shafts are more revealing. One pointed at Thuban in Draco, another at Kochab in Ursa Minor, both former pole stars at different points in the precessional cycle. The pyramid was designed as a three-dimensional astronomical map, encoding the positions of key stars at multiple epochs. This wasn't decoration. This was data storage, preserving celestial coordinates that future civilizations would need to understand orbital mechanics and predict celestial threats. The precision of megalithic construction appears globally in structures that share impossible engineering tolerances. At Tiwanaku in Bolivia, stone blocks weighing over 130 tons fit together with joints so precise that a razor blade cannot fit between them. The blocks show evidence of advanced metallurgy, copper clamps poured into H-shaped grooves to join stones together, requiring temperatures and techniques that supposedly didn't exist in pre-Columbian South America. The site sits at 12,000 feet above sea level, where thin atmosphere makes heavy construction exponentially more difficult. Why build with such precision in such an inhospitable location? The answer lies in the site's astronomical alignments. The Kalasasaya temple at Tiwanaku aligns with extreme precision to the solstice points, allowing accurate tracking of Earth's axial tilt and orbital parameters. The site functions as a permanent astronomical observatory built to survive climate change and civilization collapse. Stonehenge in England demonstrates the same pattern. Impossible precision serving astronomical function designed for continuity across catastrophe. The sarsen stones, weighing up to 50 tons each, were transported over 20 miles from their quarry source. The bluestones, smaller but still weighing several tons, came from Wales, 140 miles away. The effort required to transport and erect these stones using Bronze Age technology was enormous. Yet the site was rebuilt and modified over 1,500 years, with each phase maintaining and refining the astronomical alignments. The current arrangement creates precise sight lines for predicting solar and lunar eclipses, tracking seasonal changes, and most importantly, monitoring long-term celestial cycles. The astronomical functionality was so important that generation after generation invested massive resources to maintain and improve it, even as the original purpose faded into ritual and religion. The pattern repeats at Göbekli Tepe in Turkey, the oldest known megalithic structure predating Stonehenge by 6,000 years. Carbon dating places its construction to 11,600 years before present, shortly after the Younger Dryas impact events we discussed earlier. Here's what makes Göbekli Tepe genuinely unsettling. It was built by people who supposedly hadn't invented agriculture yet, who had no permanent settlements, no draft animals, no metal tools. Yet they carved pillars weighing 16 tons, decorated them with sophisticated bas reliefs, and arranged them in precise circular patterns oriented to astronomical alignments. Then, after using the site for roughly 2,000 years, they deliberately buried it, covering the entire complex with rubble and soil, preserving it perfectly for future discovery. This wasn't abandonment, this was intentional preservation, burying knowledge in stone for safekeeping until civilizations arose that could understand its importance. The astronomical alignments at these sites share a common pattern. They track not just solar and lunar cycles, but longer period phenomena, precessional cycles, orbital perturbations, celestial mechanics that operate on timescales of thousands of years. The Egyptian pyramids encode the Orion correlation and precessional timing. Tiwanaku tracks axial obliquity changes over millennia. Stonehenge monitors lunar standstill cycles that repeat every 18.6 years, but whose full pattern requires centuries to map completely. Göbekli Tepe's circular arrangements align with specific star positions at the beginning of the Younger Dryas period. These structures weren't built for calendar keeping or seasonal festivals. They were built to monitor celestial mechanics that influence bombardment risk. Orbital resonances, perturbation patterns, the cycles that bring cometary debris and asteroid fragments into Earth-crossing orbits. The dual function becomes clear when you consider what survives catastrophe. Libraries burn, cities flood, tablets crumble, oral traditions corrupt. But stone structures weighing thousands of tons, built with precision that ensures structural stability, aligned to astronomical coordinates that remain valid despite cultural collapse. These endure. When civilization restarts after catastrophe, survivors find these structures still standing, still functional as astronomical observatories, still encoding the knowledge their builders knew would be essential: how to watch the sky, what to watch for, which celestial cycles matter for survival. The megalithic structures are emergency protocols built at a scale that transcends individual civilizations. They're warnings and tools simultaneously, designed to ensure that no matter how complete the collapse, whoever rebuilds will have the means to resume astronomical monitoring and threat detection. The impossible precision wasn't vanity or religious fervor. It was necessity encoded in stone, the desperate work of civilizations that knew what was coming and built monuments that would outlast the fire. Prophecy isn't what we think it is. We imagine mystics in trances, seers communing with gods, pronouncements of doom delivered through divine revelation. But when you examine ancient prophetic texts with the cold eye of statistical analysis, a different pattern emerges. Prophecy was pattern recognition, probability calculation based on observed cycles spanning centuries or millennia. The priest astronomers who issued warnings about destruction from the heavens weren't channeling supernatural knowledge. They were extrapolating from historical records, calculating when celestial mechanics would bring Earth back into alignment with debris streams and orbital perturbations that had caused catastrophe before. Their prophecies weren't divination. They were threat assessments based on data collected across timescales so long that the original catastrophes had faded from living memory into mythology. Yet the cycles remained mathematically predictable to those who maintained the records. The Babylonian astronomical diaries, discovered in the ruins of ancient Mesopotamia, contain systematic observations spanning over 700 years of continuous record-keeping. These weren't casual notations. Each entry follows a strict format documenting lunar phases, planetary positions, weather phenomena, commodity prices, river levels, and crucially, what the texts call ominous phenomena, including the appearance of comets and unusually bright meteors. Modern analysis of these diaries reveals something remarkable. The Babylonian astronomers weren't just recording events. They were tracking patterns across multiple cycles, noting correlations between celestial configurations and subsequent disaster events. When certain planetary alignments coincided with increased comet activity, they documented the destruction that followed. Over centuries, this accumulated data allowed them to identify probabilistic relationships, specific celestial configurations that historically preceded bombardment events. Their prophecies about future destruction weren't supernatural insight. They were statistical predictions based on pattern matching against 7 centuries of empirical data. The Maya long count calendar, often sensationalized in modern media, encodes this same approach to cyclical catastrophe. The calendar doesn't arbitrarily start at a mythological creation date. It begins at a calculated point corresponding to the most recent major celestial catastrophe in their historical record, dated to approximately 3114 before the Common Era. From this baseline, the Maya calculated forward in cycles of 144,000 days, roughly 394 years, marking periods when their astronomical models predicted increased risk of bombardment based on Earth's position relative to known debris streams. The infamous 2012 end date that captivated popular imagination wasn't predicting apocalypse. It marked the completion of a major cycle when their models suggested elevated risk, based on patterns observed and documented across 3,000 years of continuous astronomical monitoring. The Maya weren't prophesying the end of the world. They were issuing a probabilistic warning based on the longest continuous astronomical dataset in human history. The Egyptian concept of Zep Tepi, usually translated as first time or origin moment, appears throughout religious texts as both past event and future recurrence. The texts describe Zep Tepi as a moment when order emerged from chaos, when the gods established cosmic law, and when civilization began. But embedded within these mythological descriptions are specific astronomical references. The rising of Sirius in conjunction with the Sun after a 70-day period of invisibility. Specific stellar configurations and celestial mechanics that place Zep Tepi not at a single moment but at recurring points in the precessional cycle occurring approximately every 13,000 years. The priests of Heliopolis and later Thebes maintained astronomical records calculating when Earth's axial position would return to configurations matching Zep Tepi alignments. When their texts prophesy the return of Zep Tepi, they're not predicting divine intervention. They're warning that celestial mechanics will soon replicate conditions that historically preceded catastrophe. The prophecy is astronomical calculation expressed in theological language to ensure its preservation through religious ritual. The biblical book of Enoch, Excluded from most canonical scriptures but preserved in Ethiopian Orthodox tradition, contains passages that describe angels teaching humanity about astronomical cycles and future catastrophes. The text specifically mentions the courses of the sun and moon and the seasons of the years, and describes future destruction involving fire from heaven and massive flooding. When analysed for astronomical content, the Book of Enoch contains calculations for solar and lunar cycles, descriptions of meteor showers and their periodicity, and warnings about appointed times when celestial threats would return. The angelic teachers weren't supernatural beings. They were the human astronomer priests who maintained observational records, understood celestial mechanics, and attempted to preserve this knowledge by encoding it in religious narratives that would survive cultural transmission. The prophecies of future fire and flood weren't divine revelation, but historical pattern recognition. Bombardment had happened before at calculable intervals, therefore it would happen again. The Hindu concept of yugas, vast cycles of time during which civilization rises, declines, and is eventually destroyed before renewal, follows the same pattern of astronomical observation converted into prophetic framework. The duration of the complete yuga cycle is given as 4,320,000 years, a number that initially seems like mythological exaggeration. But when you examine the sub-cycles and their ratios, they correlate with actual astronomical periods, the precession of the equinoxes, planetary orbital resonances, and the calculated periodicity of cometary bombardment based on the solar system's oscillation through the galactic plane. The Kali Yuga, the current age of decline supposedly ending in catastrophic destruction, began according to Hindu chronology in 3102 before the Common Era, within decades of the Maya long count starting date and suspiciously close to multiple geological evidence markers for significant impact events. The prophecy of the Kali Yuga's end isn't arbitrary. It's calculated based on cycles derived from astronomical observations maintained by Vedic astronomer priests across millennia. The pattern becomes undeniable when you examine how these prophetic traditions maintained institutional continuity across civilization collapses. In Mesopotamia, the astronomical records passed from Sumerian to Babylonian to Persian priesthoods, each generation adding to accumulated knowledge while preserving core calculations about celestial threat cycles. In Egypt, the priesthood of Heliopolis maintained astronomical records through multiple dynasty changes, foreign invasions, and cultural upheavals. In Mesoamerica, the astronomical knowledge passed from Olmec to Maya to Aztec cultures, each inheriting and expanding observational databases. The prophecies these cultures issued weren't based on single-generation observations or individual mystical experiences. They emerged from institutional knowledge bases spanning dozens of generations, tracking celestial patterns across timescales that individual humans could never observe, but institutional records could accumulate and analyze. The embedding of astronomical warnings in religious ritual ensured their survival through catastrophe. When civilization collapses, scientific institutions fail, written records burn, and specialized knowledge holders die. But religious rituals, repeated generation after generation, preserve information even when its meaning is forgotten. The Jewish Passover ritual commemorates escape from Egyptian bondage, but its timing, calculated using complex lunar-solar calendar rules, preserves astronomical knowledge about eclipse cycles and seasonal markers. The ritual instructions encode data about celestial mechanics in the form of holy obligation, ensuring that even if the astronomical understanding was lost, the timing calculations would survive through religious observance until civilizations arose that could decode their scientific content. This was the genius of the ancient astronomer priests. They recognized that pure scientific knowledge was vulnerable to cultural collapse, but knowledge embedded in religious practice became immortal, preserved by communities who might not understand the astronomy, but would maintain the rituals with perfect fidelity. The Hopi prophecies of the American Southwest describe a series of worlds, each destroyed by catastrophe before the emergence of the next. The prophecies specify that humanity is currently in the fourth world and detail the signs that will precede its destruction. The sky will become filled with smoke, the earth will shake, and fire will fall from above. Archaeological evidence confirms that the ancestral Puebloan cultures experienced multiple periods of catastrophic disruption followed by migration and cultural reorganization. The Hopi prophecies encode this historical pattern, converting observed cycles of catastrophe and renewal into prophetic framework. When Hopi elders warn about signs of the coming fifth world, they're not making supernatural predictions. They're pattern-matching current observations against historical cycles preserved in oral tradition across millennia, watching for celestial and atmospheric indicators that preceded previous catastrophes. The convergence of prophetic traditions across cultures reveals they're true. They're all describing the same cycles, calculated from observational astronomy, embedded in religious frameworks to ensure preservation, and transmitted as warnings to future generations. The prophecies weren't wrong about cyclical catastrophe. Geological and astronomical evidence confirms that bombardment follows periodic patterns influenced by solar system dynamics. What the prophecies encoded was the ancient understanding that these patterns could be tracked, calculated, and predicted. That survival required watching the sky with religious devotion, because the alternative was extinction. When modern dismisses ancient prophecy as superstition, it misses the sophisticated threat assessment system these cultures developed, a system that successfully preserved warnings across dozens of generations and multiple civilization collapses, waiting for descendants with the technology to understand that prophecy was always history, repeating in calculable cycles. Every piece of evidence admits multiple interpretations: the convergent mathematical precision, the astronomical alignments, the geological markers, the linguistic patterns. All of it can be read in different ways depending on which framework you choose to privilege. This is where intellectual honesty demands we examine competing explanations, not to dismiss the evidence, but to understand its full implications. 3 readings emerge from the accumulated data. 3 ways of explaining how ancient cultures separated by oceans and millennia came to possess convergent knowledge about celestial catastrophe. Each reading has merit. Each explains some aspects of the evidence while struggling with others. And the choice between them reveals as much about our assumptions regarding human capability and historical continuity as it does about the ancient world itself. The first reading is coincidence, the conventional explanation that appears in mainstream archaeology textbooks and museum placards. This interpretation argues that similar astronomical knowledge emerged independently in multiple cultures, because humans everywhere looked at the same sky and noticed the same patterns. The mathematical sophistication of Sumerian tablets reflects the natural development of civilization, not inherited knowledge. The astronomical alignments of megalithic structures demonstrate Bronze Age ingenuity, not remnant capabilities from earlier advanced cultures. The convergent flood narratives across continents reflect common human responses to local flooding events, amplified through storytelling into universal deluge myths. Under this reading, the ancient texts about fire from heaven are metaphorical descriptions of volcanism, lightning, or other terrestrial phenomena that primitive minds interpreted as celestial threats. The geological evidence for the Younger Dryas impact is real, but ancient humans didn't witness it. The event occurred before complex societies existed to document it, and any seeming references in ancient texts are coincidental pattern matching by modern researchers desperate to find connections. This coincidence interpretation has significant institutional support and explains many aspects of cultural development using well-established models of independent innovation. It doesn't require proposing lost civilizations, ancient high technology, or catastrophic amnesia. It allows archaeology to maintain linear narratives of human progress from simple to complex. But the coincidence reading struggles with specific details that resist comfortable explanation. How did multiple cultures independently develop base 60 mathematics, optimized for astronomical calculation? Why would societies at subsistence level invest enormous resources in constructing megalithic observatories with precision that serves no agricultural or calendrical purpose? How do we explain the Babylonian astronomical parameters that match modern calculations to within fractions of a percent, achieved without telescopes or computer modeling? The coincidence interpretation requires assuming that ancient peoples repeatedly stumbled into the same complex mathematical relationships, the same astronomical insights, the same engineering solutions across continents and centuries, with no contact or shared knowledge base. At some point, invoking coincidence becomes statistically more improbable than considering alternatives. The second reading is inherited trauma, the psychological interpretation that has gained traction in anthropological circles over the past few decades. This framework argues that the Younger Dryas impacts did occur and were witnessed by anatomically modern humans living in scattered populations across the globe. The trauma of these catastrophic events was so profound, so psychologically devastating, that it became encoded in collective memory and transmitted across generations through oral tradition, eventually crystallizing into the flood narratives, fire from heaven myths, and astronomical obsessions we find in ancient texts. Under this reading, the convergent knowledge isn't coincidental. It reflects shared traumatic experience. Different populations witnessed the same type of catastrophe, and their descendants independently developed similar cultural responses, watching the sky obsessively, developing astronomical knowledge to predict threats, building monuments to preserve warnings. The mathematical sophistication and architectural precision reflect post-traumatic adaptation. Survivor populations channeling collective anxiety into systematic monitoring systems and permanent warning structures. The trauma interpretation elegantly explains the emotional tenor of ancient texts, the pervasive anxiety about celestial destruction, the obsessive sky-watching, the desperate attempts to calculate when catastrophe would return. It accounts for the convergent narratives without requiring direct cultural contact or lost high civilizations. Trauma memory is well documented in modern populations. Holocaust survivors' descendants carry behavioral patterns and anxieties shaped by events they didn't personally experience. Indigenous populations maintain oral histories of catastrophes spanning hundreds of generations with remarkable accuracy. The trauma framework respects ancient peoples' capabilities while explaining knowledge transmission through psychological and cultural mechanisms rather than technological ones. But this reading also faces challenges. Can trauma memory alone account for the specific mathematical precision of Babylonian astronomical parameters? Does psychological inheritance explain the engineering tolerances of megalithic construction or the geodetic positioning of ancient sites? The trauma interpretation explains the why, the motivation for astronomical obsession, but struggles with the how. How did traumatized survivors scattered across continents independently develop identical, sophisticated mathematical and engineering solutions? The third reading is the one that makes orthodox archaeology profoundly uncomfortable: systematic inheritance from a predecessor civilization. This interpretation argues that the convergent knowledge, the mathematical sophistication, the astronomical precision, and the architectural capabilities weren't developed independently by Bronze Age cultures and weren't solely transmitted through trauma memory. They were inherited, partially, imperfectly, but deliberately, from an earlier global or semi-global civilization that possessed advanced astronomical knowledge and engineering capabilities, was catastrophically disrupted by the Younger Dryas impacts, and survived in fragmented form to seed the civilizations we recognize as the first. Under this reading, the Sumerians didn't invent base 60 mathematics. They inherited it from predecessors and preserved it because it was already optimized for the astronomical calculations that mattered for survival. The megalithic structures weren't built by Stone Age peoples learning architecture for the first time. They were built by or under the direction of survivors who remembered more advanced capabilities and attempted to replicate essential functions using available technology. This inheritance interpretation explains aspects of the evidence that the other readings struggle with. It accounts for the appearance of sophisticated astronomical knowledge in the earliest written records without a visible development period. The knowledge was already mature because it was inherited, not invented. It explains why multiple ancient texts explicitly state that their knowledge came from earlier times, from antediluvian sages, from gods who taught humans. These statements weren't mythology, but accurately described knowledge transmission from predecessor populations. The inheritance framework explains the convergent technical vocabulary across isolated cultures. They weren't independently inventing terms for celestial impacts, but inheriting and translating concepts from a shared predecessor knowledge base that had already developed precise terminology. The massive investment in megalithic construction makes sense if survivors understood these structures were restoring essential capabilities, not experimenting with new ideas. The astronomical obsession wasn't emerging from trauma alone, but from inherited understanding that monitoring celestial threats was existentially necessary. Yet the inheritance reading faces its own profound challenges. Primarily the absence of unambiguous physical evidence for a pre-Younger Dryas advanced civilization. Where are the cities, the metallurgical sites, the tool assemblages that should exist if sophisticated cultures thrived before 12,800 years ago? The counter-argument notes that 12,000 years of geological processes, sea level rise of 400 feet that submerged coastlines where populations would have concentrated, and the catastrophic destruction of the Younger Dryas itself would erase most physical traces. The megalithic structures that survive are precisely those built to survive: massive stone construction on high ground, oriented to astronomical rather than residential purposes. Perhaps what we're finding is what was meant to be found. The emergency protocols, the knowledge repositories, the survival manuals encoded in stone, while the residential and industrial infrastructure was deliberately sited in locations now underwater or destroyed. But this reasoning can become circular, explaining the absence of evidence as itself. Evidence of sophistication is intellectually dangerous territory. The honest assessment is that none of these three readings fully satisfies all the evidence. The coincidence interpretation minimizes too many convergent details. The trauma framework explains motivation, but not technical execution. The inheritance model answers capability questions, but lacks the smoking gun physical evidence we'd expect. What if the truth involves elements of all three? What if predecessor populations with advanced astronomical knowledge were catastrophically disrupted by impacts, creating profound trauma that motivated survivors to preserve and transmit essential knowledge through whatever means available? Fragmentary instruction, oral tradition, religious ritual, to descendant populations who then independently developed the mathematics, architecture, and engineering to express this inherited understanding in their own cultural contexts. This synthesis explains convergent knowledge through common inheritance, convergent anxiety through shared trauma, and divergent expression through independent development. The question isn't which reading is absolutely correct, it's which framework we choose to privilege when evaluating evidence that admits multiple interpretations. Do we default to the reading that requires the least disruption to established historical models, even when it strains probability? Do we favor psychological explanations that respect ancient human capability without proposing uncomfortable implications about lost knowledge? Or do we follow the evidence toward conclusions that challenge fundamental assumptions about civilization's linear progression, even when physical proof remains tantalizingly incomplete? The ancient texts don't resolve this debate. They simply insist, across cultures and centuries, that their knowledge of celestial catastrophe came from somewhere. From gods, from antediluvian sages, from times before the flood. Whether we interpret these statements as mythology, metaphor, or historical memory reveals our own frameworks more clearly than it reveals ancient truth. History isn't continuous. It pulses. Periods of rapid advancement followed by sudden collapse. Centuries of accumulated knowledge vanishing within generations. Civilizations rising from scattered survivors who remember fragments but not wholes. The archaeological record reveals this pattern with disturbing clarity. Complex societies appear suddenly in the record, demonstrate sophisticated capabilities from their earliest strata, flourish for centuries or millennia, then vanish abruptly, leaving behind ruins that subsequent populations can't replicate or sometimes even comprehend. Orthodox archaeology attributes these collapses to drought, invasion, economic failure, political instability, all reasonable explanations for individual cases. But when you map collapse events globally and correlate them with geological and astronomical data, a different pattern emerges. The collapses cluster at specific intervals, separated by periods of relative stability lasting roughly 1,200 to 1,500 years. These intervals aren't random. They're the silence between impacts, the breathing space when Earth's orbit carries it through relatively clear regions of the solar system before celestial mechanics bring it back into debris fields and bombardment zones. The Bronze Age collapse around 1200 before the Common Era provides the clearest historical example of this pattern. Within a span of approximately 50 years, nearly every major civilization in the Eastern Mediterranean and Near East experienced catastrophic disruption. The Hittite Empire vanished completely, its capital Hattusa burned and abandoned. Mycenaean Greece collapsed, its palace complexes destroyed, its writing system forgotten. The Egyptian New Kingdom survived but was severely weakened, losing control of its foreign territories. Ugarit, the great trading city, was destroyed so thoroughly that it was never reoccupied. The archaeological evidence shows this wasn't gradual decline. It was sudden, violent, and nearly simultaneous across a region spanning thousands of miles. Traditional explanations invoke the mysterious sea peoples, climate change, or systems collapse. But texts from the period describe something else. Fire from the sky, earthquakes, crop failures due to darkened skies, and mass migrations triggered by environmental catastrophe. The Egyptian Ipuwer papyrus dating to this period describes the Nile running with blood, likely iron-rich particulates from atmospheric deposition, and the sun being obscured for extended periods. The geological record for 1200 before the Common Era shows elevated levels of atmospheric disruption markers in ice cores and lake sediments globally. Dendrochronology, tree ring analysis, reveals a period of suppressed growth across multiple continents, indicating reduced solar radiation reaching Earth's surface. Peat bog cores from Ireland contain layers of ash and particulates dated to this period that don't match any known volcanic eruption. The evidence points to atmospheric loading from extraterrestrial source, either a major impact event or multiple smaller impacts and airbursts occurring within a short time frame. The Bronze Age collapse wasn't caused by human factors alone. It was triggered by celestial bombardment that destabilized climate, destroyed agricultural systems, and created cascading failures across interconnected civilizations. The survivors, the Iron Age cultures that emerged from the ruins, started with drastically reduced knowledge bases, having lost the administrative records, technical manuals, and institutional knowledge of their Bronze Age predecessors. This pattern repeats throughout human history with remarkable regularity. Around 3200 before the Common Era, the early Bronze Age civilization of the Levant collapsed simultaneously across dozens of urban centers. Excavations show cities burned, abandoned abruptly, and not reoccupied for centuries. The Akkadian Empire, the world's first multi-ethnic empire, collapsed around 2150 before the Common Era. Contemporary texts describe a period of darkness, failed harvests, and mass starvation. Geological cores from the region show evidence of prolonged drought, but also atmospheric anomalies inconsistent with normal climate patterns. The third dynasty of Ur, which briefly reunified Mesopotamia after the Akkadian collapse, itself fell around 2000 before the Common Era, amid descriptions of fire from heaven and divine abandonment. Each collapse shows the same signature: sudden onset, environmental disruption, and knowledge loss, followed by centuries of reduced complexity before the next civilization cycle begins. The Maya civilization demonstrates this cyclical pattern with particular clarity because their astronomical obsession produced extensive chronological records. Maya cities experienced multiple collapse cycles: the pre-classic collapse around 150 to 200 of the Common Era, the terminal classic collapse around 900, and smaller regional collapses at intermediate periods. Each collapse shows similar characteristics: rapid depopulation of urban centers, abandonment of monumental construction projects, cessation of long-count date recording, and significant knowledge loss. The terminal classic collapse is typically attributed to drought, but the Mayas' own astronomical texts suggest they expected it. Their long count calculations predicted a period of elevated celestial threat around this time. The archaeological evidence shows that some Maya populations deliberately relocated to caves and cenotes before the collapse, suggesting they had warning of impending catastrophe. The survivors who eventually re-emerged had lost much of the astronomical knowledge their predecessors possessed, though they maintained the ritual calendar structure. Between these collapse events during the intervals of relative stability, civilizations demonstrated remarkable capabilities. This is the paradox that troubles orthodox archaeology. Why do Bronze Age cultures show engineering and astronomical sophistication that subsequent Iron Age civilizations couldn't match? Why did medieval European knowledge lag behind what ancient Greeks had achieved? The standard explanation invokes the fragility of knowledge transmission. When civilizations collapse, libraries burn, experts die, and knowledge is lost. This is certainly true, but it doesn't explain why certain types of knowledge survived: religious rituals, basic agriculture, metallurgy, while other knowledge vanished completely. Advanced mathematics, precise astronomical parameters, sophisticated engineering techniques. The pattern suggests selective preservation. Knowledge embedded in religious practice and essential survival skills survived, while specialized technical knowledge maintained by small priestly or scribal classes disappeared when those institutions collapsed. The intervals between major collapse events average approximately 1,300 years, though with significant variation. From the Younger Dryas impact at 12,800 before present to the Bronze Age collapse at 1200 before the Common Era represents roughly 10,600 years, approximately 8 cycles if you accept the pattern. During each interval, civilization rebuilt, accumulated knowledge, developed technical capabilities and achieved levels of sophistication that approached or matched their predecessors. Then catastrophe struck, knowledge was lost, and the cycle restarted. The archaeological record shows this isn't smooth progress disrupted by occasional setbacks. It's cyclical. Rise, sophistication. Collapse, amnesia. Rise again. Each cycle begins with survivors who remember fragments of what came before, but lack the institutional continuity to preserve everything. They rebuild using whatever knowledge survived, often reinterpreting technical information as religious mythology when they no longer understand its original purpose. The genetic evidence supports this cyclical model. Population genetic studies show multiple bottleneck events in human history. Periods when global population crashed dramatically before recovering. The most severe bottleneck after the emergence of modern humans occurred around 12,800 years ago, precisely matching the Younger Dryas impact timing. Subsequent smaller bottlenecks correlate with the major collapse periods, around 3,200 before the Common Era, 2,100 before the Common Era, 1,200 before the Common Era. These bottlenecks aren't localized. They appear in genetic lineages across continents, indicating global or near-global population crashes. The intervals between bottlenecks represent recovery periods when populations expanded, civilizations flourished, and knowledge accumulated, until the next bombardment event reset the cycle. We are currently living in one of these intervals, approximately 3,200 years from the last major collapse, approaching the average duration of stable periods in the historical record. The silence between impacts isn't peaceful. It's the holding of breath, the watching of skies, the maintenance of astronomical monitoring systems by cultures that understood, whether through inherited knowledge or trauma memory, that the fire would return. The ancient astronomer priests weren't paranoid. They were realistic, calculating when Earth's celestial mechanics would bring it back into high-risk alignments. Their prophecies about cyclical destruction weren't superstition. They were probability assessments based on observed patterns spanning multiple cycles. The megalithic observatories, the astronomical tablets, the religious rituals encoding celestial calculations, all of it was built during the stable intervals, designed to function through the next collapse, ensuring that survivors would have the tools to resume monitoring and predict the subsequent threat. The silence between impacts was never truly silent. It hummed with preparation, with the knowledge that the sky's benevolence was temporary and that civilization's task during each interval was to preserve enough knowledge in forms durable enough that the next cycle of survivors could rebuild and resume watching the heavens for the fire that would inevitably return. Libraries aren't neutral repositories. They're acts of curation, deliberate decisions about what knowledge matters enough to preserve at enormous cost in resources, labor, and institutional commitment. When you examine what ancient civilizations chose to save in their archives, what they inscribed on imperishable materials, what they copied and recopied across generations, what they buried deliberately for future discovery. A pattern emerges that has nothing to do with literature, poetry, or historical narrative. The preserved knowledge is overwhelmingly technical. Astronomical tables, mathematical algorithms, architectural specifications, metallurgical formulas, and, crucially, warnings about celestial threats and survival protocols for catastrophe. These weren't general archives preserving cultural heritage. They were emergency protocols, survival manuals encoded in clay and stone, designed to ensure that when civilization collapsed, not if, but when, the essential knowledge would survive to seed the next cycle. The library of Ashurbanipal at Nineveh, excavated in the mid-19th century, contained over 30,000 clay tablets, the largest collection of cuneiform texts ever discovered. When scholars began cataloguing and translating this massive archive, they expected to find primarily religious texts, royal propaganda, and literary works befitting an imperial library. What they found instead was that the majority of tablets were technical manuals and astronomical records, mathematical tables, medical treatises, omen series correlating celestial events with terrestrial consequences, and detailed astronomical observations spanning centuries. King Ashurbanipal's own inscriptions describe his library's purpose: to gather and preserve knowledge from before the flood, from the antediluvian sages whose wisdom survived in scattered form. The library wasn't built to glorify the king, it was built as a knowledge repository, systematically collecting and copying texts from older Babylonian and Sumerian sources to ensure their preservation. Ashurbanipal understood his library as part of a continuity project spanning millennia, preserving inherited knowledge against future catastrophe. The deliberate burial of knowledge appears repeatedly in archaeological contexts, with a pattern that suggests intentional preservation rather than abandonment. At Qumran, the Dead Sea Scrolls were sealed in jars and hidden in caves around 70 of the Common Era, just before the Roman destruction of Jerusalem. The texts include not just religious scriptures but astronomical calendars, mathematical treatises, and detailed records of celestial observations. The community that hid these texts expected catastrophe and ensured that essential knowledge would survive in a form designed to last centuries. At Nag Hammadi in Egypt, a collection of texts including sophisticated cosmological and astronomical knowledge was buried in a sealed jar around the 4th century, likely by communities fleeing religious persecution. The act of burial wasn't concealment from immediate threats alone. It was preservation for future discovery, placing knowledge in storage until conditions allowed for its recovery and use. These weren't random hidings. They were deliberate time capsules. The content of preserved texts reveals what ancient cultures considered existentially important. Astronomical tables appear far more frequently in preserved archives than historical chronicles or poetry. Mathematical algorithms for calculating celestial positions, eclipse predictions, and planetary cycles received priority copying and preservation on durable materials. The Babylonian astronomical diaries, maintained continuously for over 700 years, represent one of the longest-running scientific programs in human history. Yet no comparable effort was devoted to preserving royal genealogies or military histories with the same institutional commitment. The priorities are clear: knowledge about the sky, about celestial mechanics, about predicting when and where threats would appear. This was deemed essential. Everything else was secondary. Cultural texts, historical records, literary works were preserved when resources allowed, but astronomical and mathematical knowledge received absolute priority, suggesting ancient scholars understood exactly what knowledge would matter most for survival. The Egyptian practice of hiding libraries within temple complexes reveals another preservation strategy. At Edfu, inscriptions describe a library of the souls containing texts from the time of the followers of Horus, a period Egyptian chronology places in the mythological past, but which references suggest meant pre-dynastic or antediluvian times. The temple library was deliberately constructed within the most structurally sound portion of the complex, protected by multiple layers of stone walls, and accessible only through passages designed to be sealed and hidden during crises. Similar hidden libraries have been found at Dendera, Philae, and other major temple sites. The texts preserved in these hidden chambers weren't random. They included astronomical ceiling maps encoding stellar positions at specific epochs, mathematical formulas for calculating temple orientations and cosmic alignments, and technical specifications for architectural elements whose functions remain unclear but which required precise mathematical relationships. The hiding wasn't from contemporaneous threats alone. It was designed to preserve knowledge through the anticipated collapse of Egyptian civilization itself. The Mayan practice of codex burial demonstrates the same pattern in Mesoamerica. Of the thousands of codices that once existed, only 4 survived the Spanish conquest. But archaeological evidence suggests many more were deliberately buried before Spanish arrival, hidden in caves and cenotes by communities who anticipated catastrophe. The surviving codices, Dresden, Madrid, Paris, and Grolier, are almost entirely astronomical in content. Venus tables, eclipse predictions, long count calculations, and ominous event correlations. Literary content, historical records, and daily administrative texts likely existed in the broader corpus of codices. But what the Maya chose to preserve in the few books that survived were astronomical tables and calendrical calculations. The Dresden Codex, the most sophisticated, contains astronomical data calculated to accuracy levels that weren't independently achieved by Western astronomy until the 20th century. This wasn't the knowledge you'd preserve if you expected your civilization to continue normally. This was emergency protocol, the absolute minimum essential information needed to rebuild astronomical monitoring after total collapse. The concept of the seed vault appears in ancient contexts with remarkable consistency. The Sumerian King List describes antediluvian sages called Apkallu, who were tasked with preserving knowledge before the flood. These figures weren't mythological. They represented an institutional role, knowledge keepers specifically charged with creating preservation protocols. Similar figures appear across cultures. The Egyptian Thoth, described as the preserver of sacred knowledge and inventor of writing, whose priests maintained libraries and astronomical records. The Vedic rishis, who preserved astronomical knowledge through oral tradition with such precision that modern archaeoastronomers can use Vedic texts to calculate ancient celestial positions. The 7 sages of Chinese tradition, who preserved knowledge through catastrophe. These weren't religious figures or mythological heroes. They were institutional roles, the librarians, astronomers, and knowledge custodians whose job was ensuring that essential information survived catastrophe through any means necessary. Writing, memorization, ritual encoding, architectural preservation, or deliberate burial. The materials chosen for preservation reveal the anticipated scale of catastrophe. Clay tablets baked hard can survive fire, water, and burial for millennia. Stone inscriptions outlast any civilization that creates them. Astronomical knowledge embedded in megalithic architecture survives when all written records fail. The ancient knowledge keepers weren't preparing for palace fires or occasional political upheavals. They were preparing for total civilizational collapse. For events so catastrophic that cities would be abandoned, languages forgotten, and entire cultural systems erased. The preservation strategies they employed, redundancy across multiple sites, encoding in both written and architectural forms, burial in sealed containers, integration into religious ritual, all suggest they expected and planned for worst-case scenarios where everything but the most carefully protected knowledge would be lost. They weren't being paranoid. They were being realistic based on their understanding of history's cyclical catastrophes. The pattern of what survived tells us what the ancients considered most valuable. Not literature, though some survived. Not historical chronicles, though fragments remain. Not religious texts primarily, though these survived because they embedded astronomical data. What survived in the greatest quantity and highest priority were astronomical tables, mathematical algorithms, architectural specifications, and warnings about celestial cycles. This is the knowledge they tried to save. Not cultural heritage for its own sake, but survival protocols. Instructions for watching the sky, calculating threat trajectories, predicting when bombardment cycles would return. Methods for rebuilding astronomical monitoring systems from scratch if necessary. Warnings that catastrophe was cyclical, predictable, and inevitable if monitoring lapsed. The ancient libraries weren't monuments to human achievement. They were emergency broadcasts to the future, messages in bottles thrown forward through time, desperate attempts by civilizations that knew they were temporary to ensure their most essential knowledge would survive them and seed the next cycle of human civilization. We stand at a peculiar moment in human history. For the first time since the ancient astronomer priests maintained their observatories and calculated celestial threat cycles, we possess the technology to detect, track, and potentially deflect objects on collision courses with Earth. Modern space agencies scan the sky with telescopes and radar systems, maintaining catalogues of near-Earth objects with orbital parameters calculated to extraordinary precision. We've mapped tens of thousands of asteroids, identified potentially hazardous approach trajectories, and developed theoretical methods for planetary defense. Yet for all our technological sophistication, we're only recently beginning to understand what the ancients already knew. That bombardment is cyclical, that Earth periodically passes through regions of increased debris density, and that the patterns they documented in cuneiform tablets and megalithic alignments match the threat models our computers generate. We didn't discover these patterns. We inherited the warning that they existed, encoded in texts and monuments we spent centuries dismissing as mythology. The modern Near-Earth Object Program, initiated seriously only after the Shoemaker-Levy 9 comet impact on Jupiter in 1994, operates on principles the Babylonian astronomers would recognize immediately. We track objects, calculate their orbital parameters, project their future positions, and assess collision probability. The mathematics is more sophisticated, the observations more precise, but the fundamental approach, systematic monitoring to predict when threats will approach, is identical to what Sumerian tablets describe. The base 60 mathematical system they developed for astronomical calculations is literally the same system we use for measuring angles and time in modern astronomy. When NASA calculates an asteroid's position in degrees, minutes, and seconds, we're using Sumerian mathematics. When we predict eclipses using Saros cycles, we're applying Babylonian astronomical knowledge. The continuity is direct, though we only recently acknowledged it. The ancients weren't primitive stargazers. They were the first planetary defense program, and we're continuing their work after a gap of millennia when the knowledge was nearly lost. The patterns they documented are confirmed by modern astronomy with uncomfortable precision. The torrid meteor stream, which Earth passes through twice annually, contains debris from comets that fragmented in the inner solar system. Modern calculations show that the density of large objects in this stream follows a roughly 3,000-year cycle, with peak bombardment risk occurring when Earth's orbit brings it through the densest regions. The timing of these peaks, calculated using orbital mechanics and computer modeling, corresponds with remarkable accuracy to the major collapse events in ancient history. 12,800 years ago, 3,200 years ago, 1,200 years ago. The ancient prophecies about cyclical destruction weren't superstition. They were pattern recognition based on observations we can now verify using instruments they never possessed. They watched the sky carefully enough, long enough to identify patterns that operate on timescales longer than individual civilizations typically survive. They encoded these patterns in texts and monuments designed to outlast their own societies, warning us that the cycle continues. The Torino scale, developed in 1999 to communicate asteroid impact risk to the public, categorizes threats from 0, no hazard, to 10, certain global catastrophe. The scale is carefully calibrated to balance accuracy with avoiding panic, acknowledging that predicting low probability, high consequence events is as much about public psychology as astronomy. The ancient astronomers faced the same challenge. How do you maintain vigilance across generations for threats that might not materialize for centuries? Their solution was embedding the warnings in religious frameworks, making sky watching a sacred obligation, and encoding threat assessment in rituals so deeply that even when the astronomical understanding faded, the monitoring continued. We've chosen institutional solutions, space agencies, international agreements, scientific monitoring programs, but we face the same fundamental problem: maintaining attention and resources for threats operating on timescales longer than political cycles, funding periods, or individual careers. The most unsettling aspect of inheriting this warning is recognizing how close we came to losing it entirely. If the astronomical tablets had all crumbled, if the megalithic structures had been completely dismantled for building materials, if the oral traditions had been fully suppressed during periods of cultural conquest, we would have entered the space age with no historical context for understanding that bombardment follows patterns rather than occurring randomly. We would have assumed our current quiet period represented normalcy rather than an interval between threat cycles. The ancient knowledge keepers understood this risk intimately. They had already experienced knowledge loss and civilization collapse, which is why they invested such enormous resources in redundant preservation methods. They encoded the warning in every medium they could devise: written records, architectural alignments, mathematical tables, religious rituals, oral traditions. They made it as impossible to completely lose as human ingenuity allowed. That we're now in position to understand and act on their warnings is testament to their preservation strategies working across 12,000 years. Modern asteroid detection programs have discovered something the ancients described but couldn't quantify with modern precision: that Jupiter acts as both shield and threat. Its massive gravity deflects many objects that would otherwise strike Earth, but it also perturbs orbits, sending objects that were safely distant into Earth-crossing trajectories. The ancient texts describe Jupiter, Marduk in Babylonian astronomy, as both protector and bringer of chaos, maintaining cosmic order while occasionally unleashing destruction. This wasn't theological fancy. It was accurate description of gravitational mechanics expressed in the only language available. When Babylonian omen texts warn about specific Jupiter-Saturn conjunctions correlating with increased firestar activity, they're describing orbital resonances that modern celestial mechanics confirms can perturb inner solar system objects. The astronomical knowledge we're rediscovering validates what they preserved, even when the scientific framework they used seems alien to modern methodology. The question that haunts modern researchers studying ancient astronomical texts is the same one that should trouble anyone who examines this evidence. What else did they know that we haven't yet rediscovered? If their mathematical precision regarding planetary orbits proved accurate, if their eclipse predictions spanning centuries proved reliable, if their warnings about cyclical bombardment are confirmed by geological and astronomical evidence, what else is encoded in texts we've dismissed as mythology or misunderstood due to our own conceptual limitations? The Sumerian tablets describing craft of the gods that move between heaven and earth, the Egyptian texts describing skyboats and celestial navigation, the Vedic descriptions of vimanas with technical specifications, are these pure mythology, or are they attempts to describe observed phenomena using vocabulary designed for terrestrial technology? The possibility that advanced predecessor civilizations existed before the Younger Dryas impacts remains scientifically controversial, but the astronomical knowledge ancient cultures demonstrably possessed pushes the boundaries of what we assumed Bronze Age peoples could achieve. We inherited more than warning. We inherited responsibility. The ancient astronomers maintained their observations and calculations because they understood that survival required continuity of monitoring across generations. They built institutions designed to outlast individual human lifespans, dynasties, even entire civilizations when necessary. The astronomical priesthoods, the temple observatories, the royal archives, these weren't bureaucratic luxuries. They were essential infrastructure for long-term survival. Our modern equivalents, space agencies, international collaborations, asteroid detection programs, are recent inventions, barely a generation old, and perpetually vulnerable to budget cuts, political shifts, and public attention spans measured in news cycles rather than centuries. The ancients built their monitoring systems to operate for millennia. We've built ours for decades. If civilization collapsed tomorrow, would our planetary defense knowledge survive in a form future societies could recover and use? Have we preserved it in stone and ritual, or only in digital archives that require functioning power grids and intact technological infrastructure to access? The warning we inherited isn't just about astronomical threats. It's about fragility, the recognition that civilization is temporary, that knowledge can be lost completely, that each cycle of human cultural development exists in the interval between catastrophes. The ancient texts describe this with brutal clarity. Knowledge that took millennia to accumulate can vanish in a generation. Cities can be abandoned, languages forgotten, entire ways of understanding the world can disappear so thoroughly that their survivors' descendants believe the ruins they find were built by gods rather than human predecessors. We are not exempt from this pattern. Our technological civilization, for all its apparent solidity, depends on supply chains, power grids, and specialized knowledge held by relatively small populations of experts. Disruption of sufficient scale would create the same cascading failures that brought down Bronze Age civilizations with the same result. Survivors struggling to preserve fragments of knowledge in forms that might outlast the collapse. The ancients knew. They calculated the cycles, documented the warning signs, built monuments to preserve essential knowledge, and embedded survival protocols in every cultural medium they could devise. They knew because they had survived catastrophe and rebuilt from the ruins multiple times. They knew because they maintained institutional memory spanning thousands of years. They knew because they never stopped watching the sky with the focused attention of populations who understood that complacency meant extinction. The question isn't whether their warnings were accurate. Modern increasingly confirms they were. The question is whether we're maintaining the same vigilance, building the same long-term institutional continuity, preserving knowledge with the same redundancy against catastrophe. Are we worthy inheritors of the warning, or are we the generation that will let the monitoring lapse and the knowledge fade, forcing our descendants to rediscover these truths the hard way when the sky burns again, and they're left wondering why no one warned them?
If you enjoyed the video, hit the like button, subscribe, and activate notifications so you don't miss our next videos.